In this video, we're going to be covering the sum or difference of cosine, sine, and tangent, and the identities related to those, and we'll just do some examples to show off the power of those identities. So we'll start with example 1 that states, or asks us to find the exact value of cosine of 15 degrees. So to be able to solve this, we should recognize that cosine of 15 degrees is the same as cosine of 45 degrees minus 30 degrees. Right? 45 minus 30 is 15, so these two things are equivalent. Then we apply the formula for the difference of, or the cosine of the difference of two angles. And that formula is cosine of the first angle, alpha, so 45, times the cosine of the second angle, which is 30, plus sine of the first angle, so 45, times sine of the second angle, which is 30. And that's our formula. We apply our knowledge of what the cosine of 45 degrees is. So the cosine of 45 degrees is root 2 over 2. The cosine of 30 degrees is root 3 over 2. Sine of 45 is root 2 over 2, and sine of 30 is 1/2. So we get the square root of 6 over 2 plus the square root of 2 over 2, or in other words, square root of 6 plus the square root of 2, all divided by 2. All right, let's do another example. So this one will ask us to find the exact value of tangent of 5 pi over 3 minus pi over 4. Okay, so for this one we use our the difference of two angles within tangent, so that identity. And if we look for that formula, we will find that tangent of alpha minus beta is tangent of alpha, which is, alpha is our first one here, so 5 pi over 3, minus tangent of beta, so pi over 4, all over 1 plus tangent of alpha, which is 5 pi over 3, times tangent of beta, which is pi over 4. Okay. And before we continue with this, we need to know what tangent of pi over 4 is and what tangent of 5 pi over 3 is. So we can, if we don't have that memorized off the top of our head, we can think about the unit circle. Pi over 4 is here. We get root 2 over 2, comma root 2 over 2 is the values on the unit circle. Tangent is opposite over adjacent, so the y over the x. So we get that tangent of pi over 4 is equal to 1. Now what about 5 pi over 3? We get pi over 3 up here, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. So this corresponds to the values at pi over 3. Sine of pi over 3 is root 3 over 2. Cosine of pi over 3 is 1/2. So tangent of 5 pi over 3, note that tangent is negative down here because the sign is negative. So this would be negative root, that should be a 3 there, root 3 over 2. divided by 1 over 2, which gives us negative root 3. Okay, so if we continue along with this, what we had written up here, tangent of 5 pi over 3 is negative root 3, minus tangent of pi over 4, tangent of pi over 4 was 1, all divided by 1 plus negative root 3 times 1. So this is negative of 1 plus root 3 all over 1 minus root 3. This negative I got out in front because I just factored out a negative out of the numerator. And that will be our solution. We'll have one more here where we're going to verify the identity using one of these formulas. So let's verify the identity. Cosine of 2 alpha is equal to cosine squared of alpha minus sine squared of alpha. So this is an identity that we can use in general while verifying other identities. But we're actually going to prove this one is true right now so that we can legitimately use it in the future. So, how do we do this? Well, we recognize that cosine of 2 alpha is the same as cosine of alpha plus alpha, which means we use our cosine of alpha plus beta formula, and that is cosine of alpha times cosine of beta, but beta here is just alpha again. So this is really cosine of alpha times cosine alpha minus sine of alpha times sine of beta, but again, our second value is alpha again, so this is really sine of alpha again. And so this is cosine squared of alpha minus sine squared of alpha, which is exactly the identity we wanted to show in the first place. So we started with cosine of 2 alpha, we made a string of equalities until we got to the right-hand side. And that concludes this video.